So, good day, my dear STEM students. So, hello once again. For today, we'll be discussing all about the rules in assigning oxidation number in each given element. Okay. What are oxidation numbers? Oxidation numbers are the numbers or the value assigned to an atom in a molecule or ions in order to keep track of the electron gain or loss. An oxidation number can be positive or negative, but the zero oxidation number is assigned only for free elements. So what are free elements? These are elements that are free in form. It is any element in an combined state, whether a monoatomic or polyatomic. For example, the oxidation number of each atom in iron, lithium, nitrogen gas, argon, and P4 is 0. Okay, so rules in assigning oxidation number. The first rule is element in a combined state or the free state have an oxidation number equal to 0. Like lithium, so the oxidation number of lithium is 0, potassium, chlorine, and hydrogen gas are all the diatomic molecule. All of those elements and molecules have an oxidation number of 0 because they are in their free uncombined state. Okay, rule number 2. Monoatomic ion have an oxidation number equal to their ionic charge. There is a simple rule in assigning oxidation number for each element. So in family A elements, all elements belonging to group 1A, as you can see based on our illustration, all of these elements, the oxidation number is positive 1. While in group 2A, the oxidation number is positive 2. In 3A is positive 3. Group 4A, positive negative 4. So, bakit positive negative 4? Kasi most of the elements found in group 4A, those elements are metalloids. Okay? So, always remember that metal always bears a positive charge or oxidation number, while a non-metal bears a negative charge. While in group 5A, the oxidation number of these elements is negative 3, then 6A is negative 2, 7A is negative 1, and then group 8A is 0. So 0 siya kasi di naman siya na-combine with other elements during chemical bond. A number 3 rule. Hydrogen is assigned an oxidation number of positive 1 in most compounds kasi it belongs to group 1A. So it's positive 1. But while in metallic hydrides such as lithium hydride and calcium hydride, these are the exemption to the rule of positive 1 oxidation number being assigned to hydrogen. So in this case, the oxidation of hydrogen is negative 1 only for these two substances or compound. The oxidation number of hydrogen is positive 1. Okay, number 4. Rule number 4, oxygen is assigned oxidation number of negative 2 in most compound. So madaling tandaan, lagi nyo lang iisipin basta pag oxygen, lagi yung negative 2, except in peroxide compounds such as hydrogen peroxide are exemption. The oxidation number of oxygen is negative 1. Basta merong polyatomic ion na peroxide, so the oxidation number here of oxygen is negative 1. This is the exemption. Number 5, ionic compounds are electrically neutral. Hence, the sum of the individual oxidation number is equal to 0. As long as wala kayong nakikitang charge symbol ng any compound, both ionic or molecular compound, automatically the sum of its oxidation number is always equal to 0. And then lastly, polyatomic ions are electrically charged. Therefore, the sum of the individual oxidation number is equal to the charge of the atom. Okay? So how to determine individual oxidation number of elements found at the middle of a ternary ionic compound? So madali mag-assign ng oxidation number, just following the rule of assigning, like in kung ano yung group niya, yun yung kanyang oxidation number. So in the case that the ternary compound, that there is element in the middle of the chemical formula, so how can we determine that the oxidation number of that particular element? So calculate the number of the underlying element. A. Calculate the oxidation number of the underlying element. For our first example, this is calcium carbonate. So the underlying element is carbon. We need to calculate the oxidation number of carbon. In the second example, magnesium nitrate, the element being calculated here is nitrogen. We need to find the oxidation number of nitrogen. So the formula in computing for the oxidation number of atoms is equal to the number of atoms times its oxidation number plus the number of atoms times the oxidation number and so on. Depende kung ilan yung elements doon sa given chemical formula. So let us begin. So in calcium carbonate, the unknown element is carbon. Kukumpitin natin oxidation number. So let carbon be our X. So solve for X. So since rule 5, the ionic compounds are electrically neutral, hence the sum of the individual oxidation number is equal to 0. So we need to equate this to 0. Okay, so let us analyze how many number of atoms of elements are present in this given chemical formula. So for calcium, as you can see, so there is no subscript in calcium. So automatically the oxidation number of the number of atoms of calcium is 1, okay? And then times the oxidation number, since ang calcium belong to group 2A, the oxidation number of that element is positive 2. Then add natin yung next element. Since ito yung unknown natin, let carbon be X. So 1 times X plus, so the number of atoms of oxygen in this formula is 3. So that is 3 times negative 2. Negative 2 is the oxidation number of oxygen, A equal to 0. So 1 times 1 is equal to positive 2 plus X plus negative 6 equal to 0. And then combine like terms. So positive 2 plus negative 6, that is X plus negative 4, and then transpose negative 4 at the right side of the equation, and then you will get X is equal to positive 4. So therefore, the oxidation number of the middle element in calcium carbonate, which is carbon, is positive 4. And then for your checking, so get the sum of all the oxidation number. So since meron na tayo nito, positive 2 plus, calcium is positive 2 plus, our computed oxidation number for carbon is positive 4 plus positive 4 plus negative 6, A, and then that is equal to 0. And then your answer is correct. Next. So for magnesium nitrate, okay, so the number of atoms of magnesium is 1 times positive 2. Since magnesium belongs to group 2A, the oxidation number of elements found in group 2A is positive 2. Then plus, since merong parenthesis in chemical formula nyo, and then outside the parenthesis meron kayong 2, so your X will be multiplied to the value of 2. Okay, kaya 2x yan. Kasi nitrogen, the number of atoms of nitrogen in this formula is 2. And then x. Kasi kukumpitin natin yung kanyang oxidation number. And then plus, the number of atoms of oxygen is 3 times 2. That is 6 times the oxidation number of oxygen, which is negative 2. And that is equal to 0. And then perform the operation. So 1 times 2 is positive 2 plus 2x plus negative 12 equal to 0. Then combine like term. So bring down 2x plus negative 10. Okay? So negative 12 plus positive 2, that is negative 10. And then you transpose negative 10 to the right side of the equation. Okay, that will be 2x is equal to positive 10. And then divide it by 2 para ma-cancel both sides of the equation. Then cancel 2. And then you will get an oxidation number of positive 5. Okay, then checking, get the sum of all oxidation number, and positive 2 times 5. Since our computed value is positive 5 and the number of atoms of nitrogen is 2, the given chemical formula, then you will multiply positive 5 to the number of atoms. And then same with oxygen. Oxygen, the number of atoms of oxygen is 6. Then you will be multiplied by negative 2. And this is equal to 0. And then this is positive 2. 2 times 5, that is 10. Positive 10 plus negative 12. Then positive 2 plus positive 10, that is positive 12 plus negative 12. And then you will get 0. Okay, then your answer is correct. But in the case of polyatomic ions, we know that polyatomic ions are electrically charged, so therefore the sum of each individual oxidation number is equal to the charge of the ion. For our example, the manganese ion MnO4 negative 2, we have to calculate the oxidation number of the underlying element. So let that element be X times X plus the number of atoms of oxygen is 4 times negative 2, which is the charge of the oxygen atom, equal to negative 2. So take note, therefore, the sum of the individual oxidation number is equal to the charge of the ion. So we will equate this not to 0 but to negative 2. Yung charge mismo. Okay, mali to. Yung negative 2 dito is the oxidation number. Yung 4 times negative 2, 2 is the oxidation number of oxygen. And then equal to negative 2, this negative 2 is the charge of the manganese ion. We have to equate it to negative 2. Okay, then x plus negative 8 is equal to negative 2. Then transpose negative 8 to the right side of the equation, and it will become positive 8. X is equal to positive 6. So therefore, the oxidation number of manganese in the manganese ion is positive 6. And then for your checking, then take note it is important to write the positive and negative sign in your final answer kasi we're dealing with oxidation number of the charge of individual atom. Okay, so for your checking, so let us add, okay, polyatomic ions are electrically charged, therefore the sum of the individual oxidation number is equal to the charge of the ion. So yung sum natin, okay, we will add positive 6. So since the computed value for manganese is positive 6, so plus negative 8, 8 is negative 8 is the total oxidation number of oxygen because we have 4 number of atoms of oxygen in the given polyatomic ion. Then that is equal to negative 2. So your answer is correct kasi negative 2. You have to equate negative 2. So your final answer will become positive 6. Okay? So this is how to compute for the oxidation number of the given element. So if you have any questions, just leave your question in our comment box. Stay safe and stay healthy. God bless everybody. Thank you.